Okay, so we're going to try chapter 4C number 17, which is a long problem. It's not a hard problem conceptually, but it is long. So this is going to go in your quad notebook, so make sure you're copying this in. It's also going to be on the test, so make sure that you understand the process. We'll practice it one more time in class as well, and if we have more time, we'll practice it a second time. So we've got the sides of this triangle on the right here, and it's formed by these three equations if we were to graph those. And then the question is it an isosceles triangle? And it looks isosceles. I mean, this side right here looks like it's about the same length as that side. But just saying it looks the same isn't enough, so we need to prove it somehow, or disprove it. So what we would need to do is figure out how long these three sides are, from here to here, and here to here, and here to here, and show that either two of them are the same or that they're all different. Now, in order to figure out how long they are, it's on a graph, so we would be able to do triangles like these, slope triangles here, and then like if this were 4 and this were 7, I could do 4 squared plus 7 squared equals c squared and figure out what this length is right here. And then I could do the same process here and the same process here and check the three side lengths. And then if it's isosceles, two will be the same. So that's really what we're going to aim for here. Now the question is, how do I figure out how long these sides are? And that comes from knowing where the points are, these intersection points, right? If I knew the coordinates of them, I could figure out my slope triangle length. So let's try and figure out where these intersections are. What we can do is we can use our calculator. So let me start up my program here. Okay. So, what I want to do, let me clear these out for a second, is I want to graph these three equations on the calculator and see this triangle, and then I'm going to use the calculator to figure out where my intersection points all are. Okay, so in order to do that, let's take out the calculator. I'm going to, let's put that on front. Okay, so in order to graph, right, normally you're in this window here where you can type in regular numbers and do regular calculations. Remember, you want to go to the y equals in order to graph things. Now, I'm going to write line 1 here. I'm going to call that one the first equation. And remember, in order to graph things on our calculator, we got to get y by itself. So I'm going to isolate the y term here. So I got plus 4x on the other side, and then I'm going to divide by 9. And a lot of students want to divide 22 by 9 and 4 by 9. The calculator doesn't care. I'm just going to put the whole top in parentheses and then divide it all by 9. So there's line 1. Y equals, I'll come over to my calculator, 22 plus 4x. Now I got to put the top in parentheses, so I'm going to come back over to the front and insert a parentheses and divided by 9. Okay, so line 2 is 2y plus 3x equals 1. So let's get y by itself. 2y equals 1 minus 3x. And then if I divide everything by 2, divide, then I end up with this formula here. Y equals, parentheses, negative 1 minus 3x, close parentheses, divided by 2. And then line 3, if you look at line 3's equation, it's already in a nice form. Y equals x minus 2. So the calculator can just graph that right away. X minus 2. Okay, so what we want to do is we want to graph in a standard window. So if your window, when you try to graph here, hitting graph, notice mine comes up just fine. But if yours isn't graphing properly, check your equations first, make sure they're okay, make sure you're not mixing up negatives and minus signs. Also, what you would probably want to do is go to Zoom and come down to Zoom Standard, number 6. And then it'll give you this negative 10 to 10, negative 10 to 10 window. Okay, so there are our 3 lines. And notice the order that they graphed in. This one went first, this one came second, this one went third. So that means the first one's line 1, the second one was line 2, and the third one was line 3. Okay, so let me shrink these down. And what we want to do is now find the intersection points. Okay, so the way to find intersection points on a calculator, I have them over here, so let me move these over, there are 4 steps, I guess, to do it. Remember, it's in the calc menu. So we need to find the calc menu, which is right here in blue. So I'm going to hit second calc, because that will give me the blue buttons, and then find the intersect feature. And then there are 3 questions, right? You have to tell it the first curve or line that you want it to look at, the second curve or line you want it to look at, and the guess that you want it to make. So let's, for example, say that I'm going to try to figure out where this particular intersection point is. So notice it's the intersection of lines 1 and 2. Okay, so I'm going to come over to follow my directions, second calc intersect, second calc intersect, number 5. And I'm going to tell it I want it to look at lines 1 and 2. Well, it's already on line 1. You can see the cursor right here as it asks me first curve. So I'm going to say enter because it's already on the line that I want. And now the cursor's here. Sometimes it's kind of hard to tell where the cursor is. You can always hit left or right to see. And you can see that the equation, it says it's on line 2. If you were on a different line, line 3, which you don't want right now, then you would hit the up or down button and it would switch which line you're on. Notice now it's on line 1, it's on line 3, now it's back on line 2 where I want it to be. So I'm going to mark line 2 now. And then it asked me to guess, so I'm going to move it close to the intersection point and hit enter. And there's my intersection point, -1, 2. Okay, so let's find this intersection point up here. I'll do that in a different color. Let's go with red. So we're going to look for this intersection point. Now that's the intersection of lines 1 and 3. So I've finished off this. Now I'm going to repeat because I need another one. So I'm going to go back to second calc, come down to intersect, number 5. And then I'm going to tell it look at lines 1 and 3. So let's move the cursor so I know which line it's on. And if you look in the top left corner, it says line 1. So I'm going to hit enter. Now I'm on the wrong line. I don't want line 2 anymore. Now I want line 3. So I'm going to hit the up or down button until I find line 3. If I hit down, now I'm on line 3. And just so you can see it, there it is, right on this line. So I'm going to hit enter. And then for guess, I'm going to move it close to where they actually cross. And hit enter. And here's my intersection, 8, 6. Okay, I've got one more intersection point down here. So that's the intersection of lines 2 and line 3. So I'm going to repeat my process again. Second calc, find intersect, number 5. And I need to tell it to look at lines 2 and 3. Now it's on line 1. I don't want that, so I'm going to hit up or down. Down takes me to line 2. Let's see, where's the cursor, just so I can see it. There's the cursor on line 2. So I'm going to hit enter. Now I'm on line 3, which is good. I want lines 2 and 3, so I'm going to mark line 3. And now for guess, I'm going to move it close and hit enter. and my intersection is at 1, -1. Okay, so now I have my 3 points. So what I want to do now is figure out, okay, what are the side lengths of my triangle? Okay, if I am moving up and down, the y values change. I'm going from 2 to 6, so that's a change of 4. If I'm going across, the x values change from -1 to 8, so that's a change from -1 to 8 is a change of 9. 8 minus -1. Right here, going up and down from the green to the blue, I am changing the y values from 2 to -1, so 2 minus -1 is 3, big minus little. And if I'm going to the right here on the bottom, I'm going from -1 to 1, which is an increase of 2. Along this line here, along the bottom, I know that I'm going from x equals 1 to x equals 8, so that's a change of 7. And then coming up here, I'm going from -1 on the y up to 6 on the y, so that's from -1 to 6 is 6 minus -1, also 7. So now I've got the side lengths, and I'm going to use Pythag to figure out how long each side of this triangle is. Okay, so I'm going to give these letters, let's call this one A, B, and C. So let's calculate AB's length, which is 4 squared plus 9 squared equals AB squared. So that's 16 plus 81 equals AB squared. And 16 plus 81 will be 97 equals AB squared. And then I take the square root. So there's my first set, root 97. Let's calculate this little one here, AC. So AC squared is 2 squared plus 3 squared. So AC squared is 4 plus 9. So AC equals 13 square rooted. And then we've got one more here, this one right here. So this one's root 13. And then the last one, if I do 7 squared plus 7 squared, I get BC squared. So this is going to be 49 plus 49 equals BC squared. So that's going to be 98 equals BC squared. And if I take the square root, I get root 98. So if you look at the three sides, you've got root 97, root 13, and root 98, which these two are very close to each other, but not equal. So since no sides are congruent, the triangle is not isosceles. And instead, it's scalene.